Hi, in this video we are going to practice balancing chemical equations. Let's get started. Let's start with this simple synthesis reaction of magnesium reacting with oxygen gas to produce magnesium oxide. To balance chemical equations, what you need to do is you need to have the number of atoms on the left side of the equation, our reactant side, to be the same as the number of atoms on the product side or the right hand side of the equation. And the way we're going to do that is by introducing coefficients or whole numbers in front of each product and each reactant. So for this example, we have one magnesium atom on both sides of the equation, so no problem there, we're balanced. And on the left hand side we have two oxygen atoms, on the right hand side we have one. So in order to balance the oxygen, we need to introduce a coefficient of 2 in front of the magnesium oxide. So now, instead of us having one magnesium and one oxygen, we now have two magnesium and two oxygen. So we've balanced the oxygen. Now the magnesium is not balanced. So to balance it, we just introduce a coefficient of 2 in front of the magnesium on the left hand side of the arrow. Now we're balanced, but let's check to make sure our work is correct. We have 2 magnesium on the left, 2 on the right. We have 2 oxygen on the left and 2 oxygen on the right. We're balanced. Moving on to our next problem. We have water, or H2O, breaks down into hydrogen gas and oxygen. On the left hand side we have 2 hydrogen atoms, and on the right we have 2 hydrogen. Perfect, those are balanced. On the left hand side we have 1 oxygen, and on the right we have 2 oxygen. So we need to balance the oxygen. If we introduce a 2 as our coefficient in front of the water, we end up having 4 hydrogen and 2 oxygen. So now we've balanced the oxygen, so we then need to go ahead and balance the hydrogen by placing a 2 as a coefficient in front of the hydrogen on the right hand side. If you don't see a subscript or a small number by the elemental symbol, then you can assume it's a 1. If you don't see a number in front of the elemental symbol, you can assume that the coefficient is 1. Silver reacts with sulfur to produce sulfur sulfide. So on the left hand side we have 1 silver and 2 silver. On the left hand side we have 1 sulfur and 1 sulfur on the right. So the sulfurs are balanced, there's no issue there, but we need to balance the silver. And the way we're going to do that is by finding the least common multiple of 1 and 2. In this case that's 2. So we need to introduce a coefficient of 2. So now on the left hand side we have 2 silvers on the left and 2 silvers on the right. So for the silver we have 2 on both sides. For the sulfur we have 1 on both sides. So that is now balanced. We have phosphorus reacts with oxygen to produce diphosphorus pentaoxide. So on the left we have 1 sulfur, and on the right we have 2 sulfur. On the left we have 2 oxygen, and then on the right we have 5 oxygen. So let's start by trying to balance the sulfur first. So one way we could try to balance the sulfur is by introducing a coefficient of 2 in front of the sulfur on the left hand side of the equation. So by doing that, we have 2 on the left and 2 on the right. Sulfurs are now balanced. On the left hand side we have 2 oxygen, and then on the right hand side we have 5 oxygen. The least common multiple of 2 and 5 is 10. So we need to get the number of oxygen on the left and on the right to be 10. The way we're going to do that is by introducing a coefficient of 2 in front of the diphosphorus pentaoxide. So by introducing that coefficient of 2, we now have 4 phosphorus and 10 oxygen. And so let's go on to the left hand side. To balance the oxygen, we introduce a coefficient of 5. And now the oxygens are balanced. Both sides have an oxygen of 10 atoms. But now, as for the phosphorus, we have 2 on the left hand side and we have 4 on the right hand side. So we're going to have to adjust here, self-correct. And instead of a 2, we need a coefficient of 4. Ideally, you want the smallest coefficients possible to complete the equation, to balance the equation. Alrighty, let's try some harder problems now. We have copper reacting with silver nitrate to produce copper nitrate and silver. Go ahead and pause this video and try to solve it on your own. Alright, hopefully you attempted the problem by yourself. Let's do it together. We have 1 copper on the left and 1 on the right. We have 1 silver on the left and 1 silver on the right. And as for the nitrate, the NO3, it's easier to treat it as a unit because it makes balancing the equation much easier. So on the left hand side we have 1 nitrate, and on the right hand side we have 2 of the nitrate. So what we need to balance here is the nitrate. Least common multiple of 1 and 2 is 2. So we need to introduce a coefficient of 2 in front of the silver nitrate on the left hand side. So now we have 2 silver and we have 2 nitrate on the left hand side. The coppers are still balanced, there's no issues there. The nitrates are now balanced. We have 2 on the left, 2 on the right, but the silver is not balanced, so we need to balance the silver. Again, least common multiple of 2 and 1 is 2, so we need a coefficient of 2 in front of the silver on the right hand side. So let's just check our work. We have 1 copper on the left, 1 copper on the right, 2 silver on the left, 2 silver on the right, and we have 2 of the nitrates on the left and 2 nitrates on the right. Potassium reacts with water, H2O, to form potassium hydroxide and hydrogen gas. Again, go ahead, try to solve this problem on your own, and let's do it together now. On the left, we have 1 potassium. On the right, 1 potassium. On the left, 2 hydrogen. We have a total of 3 hydrogen. 1 as part of the potassium hydroxide, and 2 as hydrogen gas by itself. And then we have 1 oxygen on the left and 1 oxygen on the right. So what we need to balance first is the hydrogen. Total, we have 3 hydrogen. So the way we're going to balance the hydrogen is, let's think, what number can we make the hydrogen total on the right hand side that is going to be compatible or divisible by 2. So let's say we introduce a 2 in front of the potassium hydroxide. So now we have 2 potassium on the right, we have 2 oxygen on the right, and now we have 2 hydrogen as part of the potassium hydroxide. So total, instead of us having 3 hydrogen atoms on the right hand side, we now have 4. So now the total number of hydrogens we have on the right hand side is 4. The least common multiple of 2 and 4 is 4. So we need to multiply this hydrogen by 2 by introducing a coefficient of 2 in front of the water. So now we have 4 hydrogen on the left and 2 hydrogen on the left. 2 oxygen on the left, So we've balanced out our hydrogen by having 4 hydrogen on the left, 4 on the right. We've balanced the oxygen by having 2 on the left, 2 on the right. And now the only thing we need to balance is the potassium. We have 2 on the right, 1 on the left. So that's an easy fix. Just introduce a coefficient of 2 on the left hand side. We have sodium hydroxide reacts with phosphoric acid, H3PO4, to produce sodium phosphate, Na3PO4, and water. Alright, so on the left hand side we have 1 sodium and 3 on the right. Rather than treating the oxygen on the left hand side as a total of 5, it's easier to view it as you have 1 oxygen as part of the sodium hydroxide, and then you have the phosphate as a unit by itself. So you have 1 phosphate on the left and 1 phosphate group on the right. So now it's left with our hydrogen. Again, it's easier to treat them separately. So 1 hydrogen followed by 3 hydrogen. Total of 4. We'll have to keep that in mind. And then on the right hand side we have 2 hydrogen and then 1 oxygen. Let's start with the sodium. We have 1 on the left, 3 on the right. To balance that, we introduce a coefficient of 3 here in front of the sodium hydroxide. So now we have 3 sodium on the left, 3 oxygen on the left, and now 1 times 3, that gives us 3. So total we have 6 hydrogen on the left. Alright, we've balanced the sodium. Now let's go ahead and try to balance the oxygen. We have 3 on the left and 1 on the right. So let's introduce a coefficient of 3 in front of the water. And so now, on the right hand side, we have 6 hydrogen and 3 oxygen. So the sodium is now balanced, the oxygen is now balanced, we have 3 on both sides. The hydrogen is now balanced, we have a total of 6 hydrogen on both sides. And now the phosphate is balanced because there's 1 on each side. We have mercury nitrate, react with ammonium sulfide, to produce mercury sulfide and ammonium nitrate. Alrighty, so on the left hand side we have 1 mercury atom, on the right we have 1 mercury atom. For the nitrate, again, treat that as a unit rather than individually treating it as nitrogen and oxygen, because it makes balancing the equation simpler. On the left hand side we have 2 nitrates. And then on the right hand side, we have 1 nitrate group. Moving on to the ammonium, again, treat that as a whole, as a unit, instead of treating it separately as nitrogen and hydrogen. So NH4, we have 2 ammonium groups on the left, and then we have 1 ammonium group on the right hand side. And then as for the sulfur, we have 1 on the left and 1 on the right. So we need to balance the nitrate and the ammonium group. Let's start off with the nitrate. So we have 2 on the left and we have 1 on the right. Least common multiple of 2 and 1 is 2. So let's introduce a coefficient of 2. So now we have 2 ammonium groups on the right and then 2 nitrate groups on the right. So now our equation is balanced. Copper nitrate reacts with water, good old H2O, to produce hydrogen nitrate and copper hydroxide. We have 1 copper on the left, 1 on the right. We have 2 nitrate groups on the left and 1 nitrate group on the right. we have 2 hydrogen on the left and a total of 3 hydrogen, but we'll treat it separately. We have 1 hydrogen followed by 2 hydrogen. And then as for our oxygen, we have 2 on the as for the oxygen, we have 1 on the left. And then we have 2 oxygen on the right. So the copper is balanced. The nitrate, those are not balanced. So in order to balance the nitrate, least common multiple of 2 and 1 is 2. So we need to introduce a coefficient of 2 in front of the hydrogen nitrate. So now we have 2 nitrate groups, those are balanced, and 2 hydrogen from the hydrogen nitrate, and then we have 2 hydrogen as part of the hydroxide group attached to the copper. So total we have 4 hydrogen. On the left hand side we have 2 hydrogen. On the right hand side we have a total of 4. Least common multiple of 2 and 4 is 4. So we need to introduce a coefficient of 2 in front of the water. And so now what we have is 4 hydrogen on the left and 2 oxygen on the left. And now this equation is balanced. Sodium carbonate, Na2CO3, reacts with water to produce sodium oxide and hydrogen carbonate. On the left hand side we have 2 sodium. On the right we have 2. On the left we have 1 group of the carbonate, which is CO3. Again, it's easier to treat as a unit. And on the right we have 1 of the carbonate group. On the left we have 2 hydrogen. On the right we have 2 hydrogen. On the left we have 1 oxygen, and on the right we have 1 oxygen. So this equation is already balanced. There's nothing for us to do. Moving on to the next problem. Here we have butane reacts with oxygen gas to produce carbon dioxide and water. It looks pretty daunting, but it's doable. On the right hand side we have 1 carbon and we have a total of 3 oxygen, but let's break it up to make it easier to balance. So we have 2 oxygen as part of carbon dioxide, followed by 1 oxygen as part of water, to get us a total of 3 oxygen on the right hand side. And as for the hydrogen, we have 2 hydrogen on the right. On the left we have 1, 2, 3, 4 carbon, and we have a total of 2 oxygen on the left. And as for the hydrogen, we have 2 plus 3. We have 3 plus 2 plus 2 plus 3. That gives us a total of 10. Let's start by trying to balance out the carbons first. So on the left we have 4, and then on the right we have 1. Least common multiple of 1 and 4 is 4. So let's make the coefficient in front of carbon dioxide to be 4. With a coefficient of 4, we have 4 carbon on the right and 8 carbon and 8 oxygen as part of carbon dioxide on the right hand side. So total, now instead of having 3 oxygen, we have a total of 9 oxygen on the right. So we've balanced the carbons. It's left with the oxygen and the hydrogen to balance. Of the two, the hydrogen looks a little bit easier to balance, so let's do that one first. Least common multiple of 10 and 2 is 10, so we need to introduce a coefficient of 5 in front of the water. So now we have 10 hydrogen on the right and 5 oxygen as part of the water. So total we have 13 oxygen on the right. So we've balanced the carbon and we've balanced the hydrogen. Now the issue is the oxygen. For the sake of balancing the equation, we are going to have to multiply the 2 oxygen on the left hand side by 13 over 2. That way we can have 13 on the left and 13 oxygen on the right. However, keep in mind that we cannot have coefficients be fractions. They need to be whole numbers. So although our equation is technically balanced, it can't stay like this for it to be correct. So what we have to do is we need to get rid of this fractional coefficient by multiplying this whole left hand side of the equation by 2. So now we have 2 in front of the butane and 13 in front of the oxygen. So total we have 8 carbons on the left, 20 hydrogen on the left, and now we have 26 oxygen on the left. And it's an equation, so what you do to one side, you have to do to another. Because we multiplied the whole left side by 2, we have to do the same to the right hand side. So now instead of a coefficient of 4 in front of the carbon dioxide, we have a coefficient of 8, and then instead of a coefficient of 5, we end up having a coefficient of 10 in front of the water. And so now our equation is balanced. We have decane, which is C10 H22 reacts with oxygen gas O2 to produce CO2 and water, H2O. On the left hand side we have 10 carbons, 22 hydrogen, and 2 oxygen. On the right hand side we have 1 carbon, total of 3 oxygen, but we'll break it up to make it easier to balance. So 2 oxygen followed by 1 oxygen, and then we have 2 hydrogen. Let's start by trying to balance the carbon. Least common multiple of 10 and 1 is 10. So let's introduce a coefficient of 10 in front of our carbon dioxide. So now we have 10 carbon on the right, and we have 20 oxygen plus 1, making it 21 total oxygen on the right. Let's go ahead and try to balance the hydrogen next. We have 22 on the left, 2 on the right. Least common multiple of the 2 is 22. So we need to multiply the water by a coefficient of 11. So now we have 22 hydrogen on the right, and a total of 31 oxygen on the right. We've balanced the carbon, we've balanced the hydrogen. Now the oxygen is what we need to balance. There's 2 oxygen on the left and 31 total on the right. So for the sake of balancing this equation, we need to multiply the oxygen on the left by a fraction of 31 over 2. That way the oxygen can be 31 on both sides. So our coefficient in front of the oxygen is going to be 31 over 2. And remember, our coefficient cannot be a fraction, so we need to multiply this whole left side of the equation by 2. And since it's an equation, what you do to the left, you also have to do to the right. So we're going to multiply both sides by 2. 2 in front of our decane, 31. And then for the right side, we'll have 20 in front of our carbon dioxide, and 22 in front of our water. And that's it. Here's the combustion of propane. C3H8 propane reacts with oxygen to produce carbon dioxide and water. On the left, we have 3 carbon, on the right, 1. On the left, we have 8 hydrogen, on the right, we have 2. And then on the left, we have 2 oxygen, and on the right, a total of 3 oxygen. 2 oxygen on the right, followed by 1 oxygen, making a total of 3. Let's balance the carbon first. Least common multiple of 3 and 1 is 3, so let's introduce a coefficient of 3 in front of the carbon dioxide, and we now have 3 carbon on the right and now we have 6 oxygen as part of the carbon dioxide. So a total of 7 oxygen. Now let's go on to balance the hydrogen. We have 8 on the left and 2 on the right. So least common multiple of 8 and 2 is 8. So let's introduce a coefficient of 4 in front of the water. So now we have 8 hydrogen on the right and an additional, instead of 1 oxygen, we have 4 oxygen as part of water. So a total of 10 oxygen on the right. So the only thing left now to balance is the oxygen. Least common multiple of 2 and 10 is 10. So a coefficient of 5 in front of the oxygen on the left hand side is going to balance this equation. Here's the combustion of ethane. You have C2, H6, which is ethane, reacts with oxygen to produce CO2 and H2O. On the left, we have 2 carbons. On the right, we have 1. On the left, we have 6 hydrogen. On the right, we have 2. And then on the left, we have 2 oxygen. On the right, we have a total of 3 oxygen. Least common multiple of 2 and 1 is 2. So let's introduce a coefficient of 2 in front of the CO2. And so now we have 2 carbon on the right and a total now of 5 oxygen on the right. Moving on to the hydrogen, we have 6 on the left, 2 on the right. Least common multiple of 2 and 6 is 6. So we need a coefficient of 3 in front of the water. And so now we have 6 hydrogen on the right and a total of 7 oxygen on the right. So we've balanced the carbon and we've balanced the hydrogen. Now, as for the oxygen, for the sake of balancing the equation, we need to multiply the oxygen on the left-hand side by a fraction of 7 over 2. That way we can have 7 oxygen on each side. But, again, the coefficient cannot be kept in the form of a fraction. So we're going to have to multiply the left side of this equation by 2 to get rid of that fraction. And remember, it's an equation, so what you do to one side, you have to do to the other. So we're going to multiply the other side by 2 as well. We're going to have 2 in front of the ethane, 7 in front of the oxygen, and for the right hand side, we're going to have 4 in front of the carbon dioxide, and 6 in front of the oxygen. And so now our equation is balanced. C6H6 benzene reacts with oxygen to produce CO2 and water. On the left hand side, we have 6 carbon, 6 hydrogen, and 2 oxygen. On the right hand side, we have 1 carbon, 2 hydrogen, and a total of 3 oxygen. Let's balance the carbon first. Least common multiple of 6 and 1 is 6. So coefficient of 6 in front of the carbon dioxide. So now we have 6 carbon on the right, followed by a total now of 13 oxygen on the right. Moving on to balance the hydrogen, we have 6 on the left, 2 on the right. Least common multiple of 6 and 2 is 6. So we need a coefficient of 3 in front of the water. And so now we have 6 hydrogen on the right and a total of 15 oxygen on the right. And for the sake of balancing the oxygen, we're going to have to multiply the 2 oxygens on the left by a fraction of 15 over 2, so that we have 15 oxygen on the left and 15 oxygen on the right. So our coefficient in front of the oxygen is going to be 15 over 2, but we can't keep our coefficient as a fraction, so we need to multiply this whole left side of the equation by 2. And remember, it's an equation, so what you do to one side, you have to do to the other. So we're going to multiply the other side by 2 as well. Now we just need to adjust our coefficient. We'll have 2 in front of the benzene and 15 in front of the oxygen. And as for the right hand side, we're going to have 12 in front of the carbon dioxide and 6 in front of the water. Now our equation is balanced. Potassium reacts with diboron trioxide to produce potassium oxide and boron. On the left, we have 1 potassium, 2 boron, and 3 oxygen. On the right, we have 2 potassium, 1 boron, and 1 oxygen. Let's start by balancing the potassium. Least common multiple of 1 and 2 is 2, so we need a coefficient of 2 in front of the potassium on the left side. So the potassiums are balanced. Now we need to balance the boron. We have 2 on the left, 1 on the right. So let's balance it by adding a coefficient of 2 in front of the boron on the right hand side. So great, now that's balanced. And now to balance the oxygen, we have 3 on the left, 1 on the right. Least common multiple of the 2 is 3. So we need a coefficient of 3 in front of the potassium oxide. And so now we have 6 potassium and 3 oxygen. So we've balanced the boron, we've balanced the oxygen, but now we have to go back and balance the potassium. And we do so by introducing a 6 here. So now our equation is balanced. Sodium reacts with sodium nitrate to produce sodium oxide and nitrogen gas. On the left, we have a total of 2 sodium, 1 sodium by itself, and then another one as part of sodium nitrate, so a total of 2. Normally, I would tell you to view the nitrate, the NO3, as a unit. However, if you look on the right hand side, we don't have a nitrate present. So in this case, it's easier to break up the nitrate into nitrogen and into oxygen. So on the left hand side, we have 1 nitrogen and 3 oxygen. On the right hand side, we have 2 sodium, 2 nitrogen, and 1 oxygen. The sodium is already balanced, nothing to do for that. Let's go ahead and try to balance the nitrogen now. Least common multiple of 1 and 2 is 2. So let's introduce a coefficient of 2 in front of the sodium nitrate. So now we have 2 nitrogen on the left, 6 oxygen on the left, and a total of 3 sodium on the left. So we've balanced the nitrogen. Let's go ahead and try to balance the oxygen now. We have 6 on the left and 1 on the right. So let's introduce a coefficient of 6 in front of the sodium oxide. And so now we have 12 sodium on the right and 6 oxygen on the right. We've balanced the nitrogen, we've balanced the oxygen. Now we need to balance the sodium. So we have a total of 3 sodium on the left and a total of 12 sodium on the right. So to make things equal, we need a coefficient of 10 to get 12 sodiums on the left. In this equation, we have iron disulfide reacts with oxygen gas to produce iron oxide and sulfur dioxide. On the left hand side, we have 1 iron, 2 sulfur, and 2 oxygen. On the right hand side, we have 2 iron, 1 sulfur, and a total of 5 oxygen. But let's separate the oxygen. So we have 3 oxygen followed by 2 oxygen to give us a total of 5. Let's start by balancing the iron first. Least common multiple of 1 and 2 is 2, so we need a coefficient of 2 in front of the iron disulfide. So now we have 2 iron on the left and 4 sulfur on the left. We've balanced the iron. Now let's go ahead and balance the sulfur. We have 4 sulfur on the left, 1 on the right. Least common multiple of the 2 is 4, so we need a coefficient of 4 in front of the sulfur dioxide. So now we have 4 sulfur on the right and a total now of 11 oxygen on the right. So the iron is balanced, sulfur is balanced. Now we need to balance the oxygen. For the sake of balancing the equation, we are going to multiply the oxygen on the left hand side by the fraction of 11 over 2. That way we have 11 oxygen on the left and 11 oxygen on the right. So our coefficient in front of the oxygen is going to be 11 over 2. However, we cannot have our coefficient be a fraction, so we need to multiply this whole left side by 2. And since it's an equation, what you do to one side, you have to do to the other. So we're going to multiply the whole of the right side by 2 as well. So now, let's adjust our coefficients. We're going to have a coefficient of 4 in front of our iron disulfide, a coefficient of 11 in front of the oxygen, a coefficient of 2 in front of the iron oxide, and a coefficient of 8 in front of the sulfur dioxide. Now our equation is balanced.